I'd like to thank the SME for allowing us to come today and present a topic of manufacturing and metrology. So many people may ask, well, what's this all about? Well, the discussion will really take place around automation and how to enhance your automation. Again, my name is Vince D'Alessio, and I have my colleague Jeff Reed with us today. And we are a machine tool distributor. Uh, I would say service and support provider as well. Probably, I would say we're more of a service provider than we are anything else, because in today's age, a lot of our manufacturing clients are looking for our direction, our guidance in terms of helping them get the best out of the equipment that we sell. Um, so, why automate? I mean, good question. I think we all understand that we have to automate. I don't think there's anything that I'm going to speak about today that I think most people don't already understand. But the fundamentals of a capitalist economy, it really only works when there's annualized growth. And since productivity is a key driver for growth, we have to automate. And this is not my saying. This is something that was made very clear by many economists and so on. A country's ability to improve its standard of living depends almost entirely on its ability to raise its output per worker, producing more goods and services for a given number of hours of work. So for the well-being of our economy and our society, uh, I mean, automating is a key element of that. Currently, Canada only ranks sixth in productivity against G7 countries. Not a very good record. So definitely this is an area that should be at top of mind for a lot of companies that are in the manufacturing. So what qualifies as automation? Well, first of all, let's look at the definition of what automation is. It's the technique, method, or system of operating or controlling a process by highly automatic means, by electronic devices, reducing human intervention to a minimum. So there's a lot in that sentence. But basically, a CNC machine tool, which you see a lot of today on the exhibit floor here, is automation, because you have a piece of equipment that's going to go through a completely computer numerical control process to manufacture a part. But it does not stop there. A lot of shops understand that putting a machine on your floor is only the beginning of automating a process. We need to add devices to enhance this piece of equipment, whether that's automatic loading or unloading. It could be deburring automatically. It could be auto inspection. And a big one is data collection, because with data, you have knowledge. And with knowledge, you have the ability to stabilize and improve a process. Like software, it could be an ERP, it could be CAD, CAM, simulation. And another big aspect of it is process strategy and know-how. Basically, IP, intellectual property. Every time you develop a piece of intellectual property, you're actually automating a process or a strategy. So the challenges are return on investment. In today's day and age, it's costing much, much more to start up a manufacturing facility. If you take a look at floor space, equipment, human labor, it's the cost of all aspects of manufacturing is increasing. So the return on investment becomes much more difficult, and the utilization of the equipment becomes so much more important. I mean, most industrialized nations today are facing severe shortages of workers, whether that's skilled or unskilled. I think we all understand that. And it's becoming much, much more difficult to staff evening shifts, night shifts. So therefore, there's a need to increase output without increasing labor force. So I'm going to first start by talking about, well, what kind of automation can you look at? Or can you research So there's a lot of different ways of automating the type of equipment that we present, but it could be uh, part loading into a machine, as you see with a cobot robot on the lower left side. It could be a complete FMS system, which you see on the lower right side, where you combine a bunch of machines together, a number of machines together, all integrated together. It could be a single cell with pallet loading, or it could be a robot with pallet loading. There's a lot of different ways to automate a piece of equipment. There's also the possibility of doing a custom automation where you want to move a particular material and process through a number of different pieces of equipment doing different parts. It could be material handling, part loading into a variety of different pieces of equipment. It could be going into inspection. It could be going into washing, deburring, laser marking. Automation can take a number of different forms. But it's good to understand the impact of automation and what it means to your bottom line. So let's look at how automation impacts cost. Okay, on the first row or column, you'll see vertical machining center. You'll see a horizontal machining center. You'll see a 5-axis center with a pallet loading system. And then you'll see a 5-axis machine with robot loading. And then you'll see a 5-axis machine for high production manufacturing. What I want to draw your attention to is the second line where it says cutting time percentage. And this is not information that is something that I just thought of. This is actual known within the industry, that if you have a vertical machining center, standalone machine, probably the highest spindle utilization you will achieve on that piece of equipment is about 40%. As we move to the right and we start elevating the type of equipment that you're using in your production, you'll start seeing that the cutting time percentage increases from 40% to 60% and then to 85%. And 85% is the target that we'd like to see a manufacturer company focus on as where they want to be in the spindle utilization or utilization of the equipment. So when we look at the actual cutting cost per hour, we're looking at, okay, what is that actually costing when the machine is actually cutting? Because that's when you're actually earning revenue. Okay, so if we look at the first column again, you'll see that at a capital cost of $250,000, you'll see that if I base this on a 5-year depreciation, your cutting cost for the capital is $20.83 per hour. If you look at the labor rates for that same cutting hour, the labor rate based on a 24-hour operation, and let's say in a labor expense of $30, you're looking at a total labor cost per cutting hour of $75 because you're only really cutting about 10 hours per day, right? And then we look lower here, you'll see daily operating expense. So a daily operating expense could be just an overhead that a company uses as their general overhead to run the operation. Now, it usually is done, and I've seen more and more companies do this, doing it in cost per square foot in their plant. Now, in actual fact, a lot of companies today are looking at the efficiency of their plant, and they're saying, well, I can get X amount of revenue per square foot. So, and that is actually the best way to do it, because a lot of times companies have equipment in their plant that could be 10, 20 years old, and it's still producing. And they're saying, well, why would I get rid of it because it's producing? Well, the fact is that if you replace that piece of equipment with something that is more efficient or modern, you could double or triple the output per square foot in that area of your shop. And I think that's what you need to focus on. So basically, having an overhead cost of the operation per square foot is a really good way to do it. So in this particular example here, on the first column again, you'll see that we have a overhead expense per cutting hour of about $20 as well. So if you add up the $20, the $75 and the $20, you get a total cutting cost per hour of about $116. Now, let's say you have a shop rate of $150. That means your profit per cutting hour is $33. Now, if you look at the same example as we move to the right of this chart, you're going to see that a horizontal machining center with 60% spindle utilization actually has a total cost per cutting hour of is that $90 there. And then as you move further and you become much more efficient, you look at $65, and then all the way to the right with an automated process, you got $41. So you can see very, very quickly how if you take a look at the total cost of the equipment going from $250,000 all the way over to the right of $600,000, you're increasing your investment, but your actual profit, your cutting cost per hour starts to come down. So if you plug those numbers into a calculator, and now you look at your investments, and let's look at three particular examples here: a vertical machining center at $250,000, a horizontal machining center at $450,000, and a complete automated cell 5-axis at $750,000. And you plug in the same numbers from the previous chart, where you have 10 hours of cutting cost per hour, or 10 hours of production for that spindle versus 14 versus 20. And you'll actually see your return on investment going from 4 years to 2.4 years. Now, if you translate that over 10 years, you see that the piece of equipment that you invested $750,000 for has actually gained you over $2 million of revenue. The numbers are there. And like I said, there's nothing new that I'm showing here. I'm just trying to put it in a practical way so that you can understand the benefit that automation brings to a company or to a manufacturing facility. So, but then there's also hidden benefits to automation, things that we're not really thinking about all the time, but actually forces. Automation forces lean strategies, such as activities to minimize waste, smooth production flow, because when you have a piece of equipment being automated, now the focus tends to be comes around, okay, how do I get material to this machine, and how do I get material moving out of the machine? And what we start to see when you automate a piece of equipment is you start to see that there's bottlenecks somewhere else. It creates bottlenecks. And so by going through the process of automating, you start to see the bottlenecks in your facility, and it starts to improve efficiencies in other areas. Okay? And it forces you to anticipate problems. So you can optimize your process, and you can optimize your stability. Of course, you're going to eliminate any human error, making errors in loading or process flow. And something I call daytime, nighttime strategy. A lot of times companies are developing a new process, and they do that during the day shift. Well, if you have a flexible automated system, you could be doing all of that development during the day, and then at night you can flip a switch, and now that same piece of equipment could be running production all evening. So it allows you to go very quickly from development to automation. So now comes the other topic about this presentation, and that's closing the loop, because you can automate the equipment very nicely, and it could be making parts for you all evening, but you want to be assured that it's making good components for you throughout the evening. So closing the loop in the automation is very, very important, and maximizing the benefit of unattended production. And that's, you have to understand the process stability to reduce non-conforming part production and to lower your scrap rate. And at that now, I'm going to leave this part of the presentation and hand it over to Jeff, and he will give you an insight in terms of how we could close the loop in an automated system. Thank you.
Oh, the clicker. Thanks, Vince. And thanks for everyone for the opportunity to be on stage here at CMTS 2023. As Vince mentioned, for this part of the presentation, I'll be concerned with more metrology products. and how we close the loop. I'm going to touch on a couple of broad topics, one of them being interconnectivity between production and metrology, putting your data collection on autopilot, and a little bit about the future. We're going to mention what a lot of talks this week have been about, which is AI, or more importantly to me, machine learning, and we're going to touch on Industry 5.0. And by the way, if I say anything up here that piques your interest, feel free to come up to me or contact with me. At the end of the slide, I'll have my contact info, and we can reach out and have a one-on-one conversation. So I'm just got to advance this. What do we really say when we mean closed loop manufacturing? We can simplify it a bit by talking about some of the steps. For closed loop manufacturing, we collect and analyze real-time data from the various stages of production. We provide continuous feedback of that metrology data to the manufacturing process. We then adjust the process for optimal efficiency, and that's a closed loop. We do this to achieve the highest part quality, matching the characteristics of the intended design. So, I got to go backwards. So current innovations in metrology. So the conventional CMM and the methods we use for inspection for the last 50 years are making great advances in terms of sensors and speed and software, data management software. And we have some new advancements in advanced technologies, X-ray, 3D scanning, optical systems, and this is all fantastic. But what is the end result? The end result of all of this is large amounts of data. The product of metrology is data. A lot of people miss that fact. This data is very valuable to us, not only because of the cost that it incurs to obtain it, but for what it can do for us now and in the future. And what do we want when it comes to data? We want reliability. Do I have a device or a system that's producing the accuracy and precision that I can use to make informed choices and adjustments to my process? And an abundance of data. Do I have enough data to make a decision? If you give me 1 point, I know where I am. If I have 2 or 3 points, I can sort of tell where I'm going. But if we have 1 million data points, we can predict the future. So nearly every metrology product we're currently working on involves some form of automation. That might be a CMM or an optical system, 3D metrology. All of it is centering around automation these days. How do we get there? This is sort of a list step by step, but we work closely with industry experts such as Elliott or other product managers that have done it before, and most importantly, someone who can service and support the project. This is really key. Next step really is to set a goal. I want to automate this process by the end of the year as a test bench. We take stock of what technology we have, identify how it can help, and target new technologies that would make the project more successful. And one of the things I tell people is just to stop waiting and get started. If you're always waiting for the next best thing to come out, you'll never take that first step to get moving. And once we do get moving, take it 1 step at a time, because implementing everything all at once often overwhelms your current processes, and it's never a successful approach. We have to gather objective data from our process as we go, and we have to collect it automatically without adding human labor costs or interference, because humans are fallible people, and they'll make changes to data on you. So we put that on autopilot. We have to then continuously improve what we've created, iterate it. Don't be afraid to make mistakes and collect those lessons learned. And that brings us to essentially the entire solution. We have a process that's automated with metrology and software, and that's a closed loop between manufacturing and metrology. In this picture, we have a conventional CMM, which is considered by many to be an older technology. We've integrated a cobot onto the corner, eliminating someone loading and unloading parts and reducing our costs. So how do we put our production processes on autopilot? Within processes where tool management or certain parameters can be adjusted, a CNC cell or some other production we close the loop to provide tighter dimensional control, and we can extend our tool life or increase process capability. In other words, we lower our scrap rates, we produce better parts at higher production rates, and we have a lower overall cost of goods sold, as Vince showed us with his previous slides. And these processes, this closed loop, can be done by various methods. They can be simply statistics-based, the common SPC that you're used to working with now. They can be PID-based if we take a more engineering approach, or machine learning, and possibly by your own AI agent one day. So when we do that, we are adding machine learning or AI. We have Industry 5.0. So Industry 4.0 was the IoT, connection of things in the shop, providing data. We're still not there in Canada. We could use a lot more of Industry 4.0, but Industry 5.0 is the next phase of industrialization where we see humans working aside advanced technologies like machine learning and AI. And there's a lot of confusion between AI and machine learning, but you can think of AI sort of like your Siri or Alexa. It's a software to mimic human interactions, to make interaction with machine learning much more approachable. So, for example, on a CNC lathe, we can set up a software to collect data about how to react appropriately when a new bar is loaded. That data can be provided from within the CNC itself in machine probing, a gauge or a CMM, vibration data, temperature data. Any number of data providers could contribute information to that decision. And then the machine learning system evaluates that data collected over a sufficiently long period of time and can create a machine and environment specific predictive offset. So we can make perhaps a few more good parts rather than possibly having a marginal part as the first part off of a new bar. So we can see machine learning software can look at vast amounts of data and assist us in making decisions about our process, our tool life, extending the tool a few more parts, or changing the tool earlier to improve quality and increase process capability, to adjust our feeds and speeds, or simply what coolant and inserts gave us the best quality parts. It can even tell us that the operator is opening the door too often and hurting our environmental stability. If we take it one step further and we take our machine learning system and we add an AI agent to assist you to rapidly analyze a lot of vast amounts of collected data, imagine what it could tell us. And that's what we're talking about with Industry 5.0. There we go. So that sort of wraps up everything I had to go over this morning, and I touched on a number of topics, and we discussed software and hardware interconnections, how to make a good control mechanism, how we can make data-driven decisions about our process, and how AI and machine learning are changing the future when it comes to automation and process control, and a little bit about Industry 4.0. Oops. So, I really enjoyed my time on stage. As I mentioned, please feel free to reach out to me about anything I've said if it's piqued some interest. I'm happy to speak with you about any of these topics. My stuff is on screen. Take a photo. And thank you very much for your time here today.